Good afternoon, everybody. Yes, it is awful early for me. Maybe it is because yet not time for me to go to bed even. I am going to talk to you today about mapping system-level coverage metrics that are perhaps envisioned differently than other kinds of coverage, and how we're mapping this to traditional coverage models from our perspective, such as UCIS. So the agenda for my talk: I'll give you a little bit of motivation as to why we're doing what we're doing, which is we're generating system-level tests for SoC designs. I will talk to you about the strategy of how we're generating these tests. I'm going to spend the bulk of my presentation talking about how we do coverage modeling for system-level tests. Then I'll talk to you about how those models can be mapped to UCIS-style coverage. And finally, I'll give you my conclusions. So let's go to motivation. The fundamental problem that we're trying to solve here at Brecker is down at the IP and subsystem level, we tend to have transactional test benches like UVM. When you're building a complex SoC, eventually you'll put real software like Android on it and running applications. But in between, there's a big gap where we need to do a bunch of bare metal diagnostics to properly test both in simulation, emulation, and post-silicon that our systems are running correctly, and we want to push the hardware without worrying about whether we're facing software issues. That's the problem we're solving. So how do we do this? It turns out today what people are doing for this SoC level testing is they're handwriting a bunch of C-tests that run on their SoC. And of course, you can only write a few simple tests if you're doing it by hand. At Brecker, our overall strategy is to generate those C-tests based off of something that we'll call a scenario model. So scenario model is based on a graph-based constraint solver, and really the scenario model is the coverage model of the system, and we're going to talk about how we do coverage modeling for a system. So let's talk about coverage modeling. What do we care about for system-level coverage? Well, we are no longer after bits and bytes in the implementation. We want to know whether we've taken our system through all of its use models. One aspect might be, have we covered all of our driver scenarios? Has each IP been taken through all of its configuration cases? A different case might be application coverage, which to us will be, have we done all the producer-consumer use cases where multiple IPs play together to create some system scenario? A third level of coverage might be more temporal. We might want to know, have we seen the appropriate concurrency cases where multiple drivers have run at the same time? So these are all very system-y, software-y concepts that we're trying to map back to coverage as we understand it. So what might be some driver-level scenarios? As an example, let's consider a digital camera subsystem. We might have one scenario that has to do with a camera taking pictures. It might be able to do this in multiple modes. We might have another scenario for how a photo processor takes that, takes the output of the camera and processes it in various modes. So these are each single IP-based scenario cases. Well, it turns out that it's possible to map all those cases in what we're calling a scenario model, which is basically a graph that encodes all the possible modes that we could exercise a specific driver in. And each path in this graph gives us a different use case that's possible for that driver. We might extend this idea further up to application-level use cases. For example, there might be one use case where we're taking a picture, is this yellow case, where the camera takes an image, is processed to a JPEG, and written out to an SD card. There might be a different use case where we're going to read an image from an SD card, decode it, and display it out to the screen. So various use cases that involve multiple IPs. Well, it turns out that you can use the same graph-based scenario models to map all the different producer-consumer use cases that your system can support. For example, there's the case of taking a picture and saving it to the SD card controller. There's a case of looking at a picture that you've already had, where each of these blocks, of course, are containing the driver level graph that I showed you in the previous slides. So in this way, we can map all the possible use cases, both at the driver level and the system level, for the system. From these models, we are going off and generating C test cases for the system, self-verifying C test cases. And we are also able to give you sophisticated scheduling, where, for example, in this GUI, which is showing the output of the tool, output of our tool, we're able to show you the various processors that are running in the system, the various threads on the system, which operations have completed, which operations have not, and show you the producer-consumer relationships between various drivers in the system. So this is both a visualization of what tests you have and a debug platform for tracking what's going on and when. And since we have the information of when, we know when these drivers are triggering and when they're finishing, this is the premise of how we get our temporal coverage, which, by the way, can be mapped right back to a graph in the scenario model. Another nice aspect over here is, since you have the scenario model that is abstracted away from system Verilog or a simulator, and you're generating the C tests, they can also run on silicon. So you might have some target board that's running with a debugger per usual in a post-silicon environment, and the same debug processes work via debug port on the board, such as a UART or a USB port. So now we're able to do coverage of the scenario models that not only run in simulation, but you're also being able to measure coverage on your post-silicon test cases. So far I've told you a story that says there's some graph-based model that can model the drivers, model the applications, and generate tests. Now let's look at how we can look at the coverage of these models. So for one thing, we can visualize them. We can generate pretty pictures of these graphs. Another thing that becomes very viable with scenario models is you can do reachability analysis. So this presentation is more about how we map to UCIS, so I haven't gone into details, but there is a graph-based constraint solver that makes the graphs very compact. But you always want to ask the question of, am I over-constrained? And in this reachability analysis view, you can look at the graph and it'll tell you which paths are reachable, which paths are not reachable. So this plays into our conversation of the exclusion cases in our coverage. The tool also tracks what paths in the model have been exercised, and that can be viewed in the graph itself. So you can look at whether nodes have been visited, whether all the paths have been visited, and this is the coverage information we're looking for. So now let's look at how we can map this information out to something like UCIS. So the fundamental aha is that, yes, we might have some complicated hierarchical graph that is describing all of the use cases in our system, but fundamentally we are having a conversation of, have all paths in the graph been exercised? And the main trick is that the scenario model typically has a stupidly big number of paths. Having 10 to the 30 paths in the driver is nothing. Having 10 to the 300 paths for a system is nothing. And obviously we don't want that many bins in our coverage database because we're just simply not going to satisfy them. So the idea over here is that you prune the graph into the cases that you care about, and then make the pruned graph your coverage model, and paths in that graph become bins in your coverage model. And since the scenario model can already determine what paths are reachable and what paths are not reachable, these are automatically excluded for you. This coverage model, which is a layer on top of the graph, can be constructed either visually or via an API. And we have done a UCIS-style iterator-based API to query those results, to export them to various other coverage databases. And the concept over here is that in theory, we want 100% coverage of all paths. This is a stupid big number, and nobody's going to achieve it. But perhaps we might decide, we might create various cover groups, maybe one for each driver, maybe one for all of our applications, where in the application level coverage, We're interested in knowing whether various drivers have played together, but we don't have to check the complete cross product of every combination of every driver. There will be paths in the graph that talk about power management and other system management coverage. Those can be extracted and so on. So, in conclusion, at Brecker here, we are focused on the automatic generation of system-level C test cases for SoC designs. The strategy is to generate these C tests from something that we're calling a scenario model. And really that scenario model is all about coming up with a coverage model for the system. And it turns out that you can take that graph-based model and map it to UCIS without much fuss. Thank you very much.
Okay, I've just got one question, please, Adnan. So you're building this system coverage on top of the existing coverage that's built into UCIS. Do you see any scope for actually extending UCIS to specific system goals, or do you think the current coverage bins and coverage groups is sufficient for your system level coverage?
That's an interesting question. I think at Brecker we haven't gone far enough into the UCIS data models to know the answer, but the fundamental concept lies around you have the scenario model with some stupid number of paths in it. You are taking various cuts into this model to pull out coverage you're interested in. And there's a conversation of perhaps we need to be aggregating individual cover groups into higher level cover somethings so that we can look at what coverage has been reached, what coverage has not been reached. So right now a lot of this can be done directly on the graph-based model, but I suspect this accumulation, I think we were discussing this a little bit earlier, tying it closer to the test plan and having that hierarchy maybe where the conversations lie around.